Hello, hello. Sorry. Okay, so we are live now, and we'll be solving problem S from DP atcoder. Okay, and yeah, let me clean this. Okay, so this problem is like this problem was out of my scope. I couldn't even thought like I couldn't even think how to begin, how to start thinking in this. What am I saying? So basically, this was out of my league, and so I took some help from internet and different YouTubers, and now I think I understand how this problem is supposed to be solved. Okay, so let's go over the problem once more. Let me check my mic is okay. So we are given a range, basically 1 and k, and we have to find the number of integers between them such that sum of digits in base 10 is a multiple of d. Okay, so this problem would have been very easy if the constraint was not this large. Okay, this is basically the number, the range we are getting is it has a length, it has like 10 to the power 4 digits in itself, right? So yeah, this is not possible using normal traditional methods. So to solve this problem, of course, since this is a DP contest, so there is only one thing, that is digit DP. So this type of problem is solved using digit DP, that I got to know. And so how to proceed? So basically, since we are given the range like this, so we have k going from k going from 1 to 10 to the power 4, right? 10 to the power 10 to the power 4, and d we have going to 100, sorry. Okay, so we have this and since this is such a large number, we cannot store it in a in like 64-bit or anything, so it has to be stored in a string. Okay, it has to be stored in a string. Okay, so suppose, let's take an example. We have okay, so what are the main observations? Let's say we have k as 1 2 3 4 5. Okay, what are our main observations? So if this is the k and we want to get all the numbers less than this but greater than equal to k and less than equal to k, which should have the digit sum as a multiple of d, right? Okay, so then only the mod d will be 0. So we can try making the digits, right? So we can try putting integers in its positions, for example here. Okay, so in this place what we can see is that the only option that we have is putting the only options we have is are putting either 0 or 1. Okay, why? Because if we go to like 2, maybe if we put 2, then it will be greater than k, and that is not that is not and then we are not supposed to go beyond k, right? So we can only go 0 and 1. And similarly for every corresponding digit, okay, we can only go up till the whatever ith position, corresponding ith position in k. Okay, but 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 if we have taken 0 here, let's say if we have taken 0, then the thing is that we are already less than k. Okay, so it doesn't matter if for the coming places here we put 9 or anything, because it will still be less than k. So the main observation is that if in filling the places, if you take a digit less than k, then that means for the upcoming or for the coming digits, you have freedom in choosing the numbers, right? This is also like can be called tightness, maybe, or what? Okay. So for the DP state, okay, also one more thing, while building the number, we also need the sum of it, right? Sum of digits, we also need sum of digits. So we can do what we can do is we'll build the entire number, and then, or maybe we'll have a sum in the DP state, and at the end, when we build the entire number, that is when our pointer reaches the size of k, then we can check whether the sum mod d is equal to 0. If that is the case, then we'll increment the answer by 1. Okay, that, or what we can do is for each individual place we can have the sum at the last place and whatever digit we choose at the current place, and we'll add them and then save the mod for this place. So for example, if we have 1 2 3 4 5, okay, and we have chosen till now 1 0 2, and for this place we are thinking what to choose. So we have the sum 1 0 2 3. Okay, so suppose if we choose 4 itself, so it will be like 3 plus 4 mod whatever d will store here. Okay, got it? So we'll store it here, and similarly for this place. So okay, so we need so for DP state, so for our DP state, what do we need? Basically we need I, which is basically the position in the string, position in k. Okay, we need the tightness. Okay, we need the tightness, let's just say tight, and we also need what? Sum of mod. Okay, we need this. And what does it represent it basically represents till ith position of k. If we have built a number, uh, if we have built a number with with some mod, then what is the answer? Like that. Okay. So the answer will be in 0 only, but still we need to calculate all the number. So it is nothing but till ith place of k the number of count of numbers built tight or loose. Basically it means we have we have reached the upper bound or not, that has digit sum mod equal to sum mod. So if you want 0, so it will be 0. So this is the state that we have. What is the base case? Base case is if I is double equal to k size. Okay. In that case, if we see that sum mod is 0, then in that case we'll just return 1. Okay, the 1 will be returned. So how will the transit? Hello. 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 Okay. So there is some issue with my stream OBS. I don't know. It disconnects frequently. So anyway, we were at transition set. So how will the transition look like? So let's see. If we have k as 1, 2, 3, 4, 5, 6, so there can be two cases, right? So there are two cases. So for filling this position, maybe we may have the previous number looking like this, or we may have them looking like this. Okay. So now for the current position, we have two options. Okay. Basically the limit only increases. Here we can only go till 3, right? And here the limit is broken. We can go till 9. Why? Because this number is already less than this. Okay, so we can go till 9. So there is that. So if the previous numbers are tightly packed, in that case the limit basically becomes whatever k kith position we have, otherwise it will be 9 only. And since we have the limit, what we can do is we can try to put our numbers in this place, right? From 0 to that particular limit we can do basically the dp or like this, it will be dp and whatever I that we have. Okay, think about it. We have solved till I, so we want to solve for I plus 1, right? So it will be dp I plus 1 only, and we have either tight or untight, right? So we have tight or untight, no, maybe tight or loose. So how do we transition from one state to another? Wait. So if it is tight, that means the future states will also be tight only, right? So it will be shared with the future states. Okay, and then we have some mode. Suppose we take what? Suppose we take this number. So let's say d, small d, sum plus d and mod d, and this will be This will be added with the current DP and if it is tight or not. Okay, uh, not like this. So if you do it recursively, okay, and I'm not going to do it like this. So the thing is, this thing is okay. Suppose we have we are doing it recursively, right? So we will have dpi tight, and we'll also have the mod sum. Okay, we will be adding this with the future positions value. Okay, and here tight will either be this, okay, or it also depends on, for example, if you're taking it to 0 to limit, right? This or depends. So if we take j as limit only, that means we are tightly packing it, right? So if not, then this means it is loose. This means it is tight. Okay, so what does this mean? Tight means we can only have this, right? So this condition will be this only, and other than this we have whatever some mod we had plus the digit we took and their mod. Okay, and at the end we'll return this only. Okay, so this will be our kind of transition. How about the answer? What about the answer? The thing is, answer the okay, so for answer we will calculate dp starting from 0, it is tight, and mod is 0, plus dp starting from 0, it is not tight, and starting from 1, some mod is 0. Both of these minus 1 and its mod. Why minus 1? So basically in inputting all the values we are also choosing 0, but in the question the range is from 1, right? So we'll have to subtract 1. Okay, So this is the solution, whatever I could understand from the YouTube videos, and based on that, okay, mostly that, but I think it will not work just because I'm very bad in implementing them. Okay, so let's go for a recursive solution here, and before that we'll have we will have of course a string k. Okay, we'll have an integer. Okay, and then we'll have a dp. 3 states. Okay, the first will be 10 to the power 4 plus 1, so like this. Okay, second will be 2 because it is a boolean. Third is this, because d can be like up to 100, so mod will be till that only, and then we'll solve it. Let's just name it deco. We have the I, we have the tight, we have the mod sum. Okay, and if I reaches n, which is basically k dot size, and in that case if mod sum is 0, then we'll return 1, and else will return 0. Okay, we will also get our answer from here, which is, or basically we will mean set it and then do something about it. Okay, so if dp I tight mod sum is not equal to -1, then we'll just return it. Tight mod sum. Otherwise we'll have answer, we'll return the answer, and in between we'll have a limit where the limit will go from, of course if it is tight or not, we'll check. If it is tight, then the limit will go from ki minus 0 or 9. Okay, and for d going from 0 to our limit, of course we want to include the limit, so cf, and we'll do answer plus equal to our deco and I plus 1 tight, or the d is less than greater than equal to limit, and it will be mod sum plus the d we have chosen, and we will mod that. So this should be the, okay, so we'll see in k, we'll see in d as well. Okay, and memset dp minus 1 size of dp. Okay, set with minus 1, and the answer is vertex starting from 0, 0, mod sum initially is 0. Okay, mod sum initially is 0 plus deco 0 1 0 minus 1 and mod. We'll see out the answer. Let's just take a sample input, run it. Okay, so we are not setting the dp here, so we'll set the dp and it will be mod sum. So it is giving answer as 1, which is not correct. What about this one? So it is giving minus something, 6352708. So maybe an issue with mod, I think, or maybe we don't need this. Okay, so when we are adding, we are not modding it, so that is why. Anyway, this is not correct, so what to do? Maybe I don't need to insert it. We'll do like this. Still the same. Oh, it's not mod. It's D now. Damn, bro, damn. Oh, this guy solved it very differently. It doesn't really change anything, does it? This the thing, same thing. Okay. Also, if it is -1, then okay. So the thing is, if it is I don't understand this. What does tilde do? Tilde actually inverts every bit now. So if it is -1, that means everything is 1 in the bit. And if we revert that, then it will be false, and then it will not work. The answer is 0. Okay, so otherwise, if we have 1, then how does this work actually? It's the same thing. Okay, we don't have the base case. No, we have. Okay. Mm. Wrong answer. TLE, MLE, TLE. Time complexity k into mod sum into 2. That should have been the case, but it doesn't look like it. Okay, so we will need to go that route. We'll also do that to DDP. Okay. Okay. It is 0 only, we don't need to do mean set. Okay, so if we don't have any number, and if k is 0 or if k is 1, in that case the answer is 1 only. Okay, then we'll go from where? N. Okay, and we'll check the digit. Check the digit, and then we'll go for the tightness. Okay, After that, we'll go mod sum. 0 to 100. Okay, and we'll check if our DP on this thing mod sum is 0. If it is 0, then we don't do anything, we'll just pass, because we don't want it to be, we don't want it be adding in future solutions, because it will not contribute anything, it will just waste time. Okay, and here we will have our next sum, which is mod sum plus whatever digit we have chosen. I think so it will be course we need a limit as well. So if it is tight, then our limit will be digit, otherwise it will be 9. And of course we will go from 0 to that limit and calculate these things. Next iterate, if t is double equal to limit mod sum d mod d. Okay, we have this, then we'll do this, we'll do next iterate, we'll do next mod sum plus equal to dpi iterate mod sum, and all of which will be modded like this. At the end, the answer will be in dp n10 dp n00 minus 1 plus mod on mode. Show it to the people. Let's run it. Same answer. Same answer. Same answer. copy it, paste it, verify it, submit it. Wrong answer, TLE, MLE, wrong answer, TLE, MLE, wrong answer, TLE. Nope. Execution time 35 millisecond. Code size is little bit higher. Score is same, everything else is same. And with that, I think it's the end of the stream. Yep, we can end the stream now. Yeah, so I will admit it that these questions are very high level, and I don't have enough knowledge on digit DP, so I'll be practicing that. And the question I did, I of course used YouTube and other sources to learn first, and still then the implementation part was not correct only. Otherwise, the how the solution is how the solution is working, that part is clear to me. Okay, implementation maybe okay, but if you have clarity, then implementation will should be easier, right? But yeah, yep, I do a lot of implementation mistake. I have seen it in previous problems also. The last that graph problem, I think walk problem. There also I used 32-bit integer instead of 64-bit, and that is what was causing all the wrong answers. And I think it took like 20 to 30 minutes of debugging, maybe, because we only solved one question yesterday and today as well. Yeah, so yep, the main thing is implementation for me, and yeah, I'll work on that. Yep, and learn digit DP. There is also bit masking. Okay, also the math needed, like combinatorics and like geometry problems. Okay, and then we will move to graph, segment tree and all, and binary search, things like these. So we have a lot coming up, and of course this year it's I think by the end of this year I would like to do a switch, so we will be doing lead code as well. I think we will be moving on to lead code. We will solve some problems on lead code, and also we will be doing project activities. I have been saying this for like last maybe like couple of weeks, but still I haven't thought of a project idea yet. And yeah, so we have a lot to do, and I hope you as well, because who would want to do nothing on a new year, right? That's so wait, that's kind of cringe, but still okay, so yeah, I hope you have a very good night, and